In this video we will see the real power of our new input-output method. Now I've generated the new circuit here, and this circuit is available for you in the resources section. So you'll be able to open up this circuit and compare it to the old circuit. Now rather than taking the old circuit and making all the changes to it, which would be long and it would be rather boring for you just to sit and watch me making the changes, I've created the new circuit here, and we will talk through the new circuit and we can make a comparison with the old circuit. Now we can forget about the top level for the moment and we'll go into the CPU. So the first thing to note here is that I've got rid of the RAM, and we're going to place the RAM on the top level, and we're going to replace the RAM with a Logisim equivalent RAM. Now this isn't a cop-out. The RAM that we've generated is slow and cumbersome, and the Logisim RAM will be really fast and really efficient. And in essence, it's just the same block. It's just going to allow us to run our programs a lot faster. So we can quite easily get rid of this and put a Logisim RAM at the top level. But if we're going to do that, then there's some signals we're going to have to take out to the top level. So for example, the signal from the control section setting the memory address register. So we've got an extra pin here called memory address register set. We've also got the RAM enable and the RAM set pins coming from the control section, and those have to go to the top level. Now, whenever we got rid of the RAM, we also got rid of the memory address register. So we have to generate a new memory address register, and that's what I've generated here. So it's just simply an 8-bit register. So we have a value up, a component up here called CPU register _ 8. So this will become our new memory address register. So the memory address register is going to receive information from the bus, and it's also going to output that information to the next level up. So we've got an 8-pin output, which is called memory address register. So this is a new pin, and in effect what we have here is an address bus. So previous to this we only had one bus, and it was the main bus that ran through the outside that carried both the data and address. But now what we're going to do is we're going to have a separate address bus here which goes to the outside world, and this is what you would tend to see in a CPU. You would have an address bus and a data bus. So that's what we will have here. We'll have this bus here will be the data bus, and this bus here will be the address bus. Now we won't be keeping that forever, because whenever we look at memory mapped I/O, it's going to change slightly, but that's the way we're going to do it for the moment. Now this memory address register, again, it's just set as it was previously via the memory address register set. So I've taken a little tunnel here and I've placed it here. It's got its reset, and remember that the memory address register wasn't enabled onto the bus, it was just set. So we just connected that enable to a value of 1. So that's us talked our way around about getting rid of the RAM. But whenever we get rid of this internal RAM, we also had a section here, if you check the original your previous diagram, we had a section here that loaded up the RAM. So it counted up to 256 and loaded the program into the RAM. Well, we no longer need this because the RAM's in the top level, and we'll deal with that on the top level. Now another thing to note here is that if we were to get into the control section is a lot simpler, because we're not using any of the previous methods that we used in order to load up the CPU. So there was a whole load of gates here which I've got rid of. We'll have a look at them in a minute in the previous one. And there was a few gates here and there that I had added in order to get through the loading process. And also there was a set of gates here for the load as well. And those have all gone. So it means that the control section is a lot neater and a lot tidier, and it's a bit simpler. So let's go ahead and we'll have a look at the old control section, and we'll just see the bits that have been taken out. So this is the old control section, and we are able to take out the gates that we have here. So I included all of this in order to load up the internal RAM. So all of that can go, and this L1 and the extra OR gate here, it can go, and this section here can go as well. And the load here, which is a command that comes out from the instruction, that can all go, and this little circuit here can go as well. So all of that was added in the previous course in order to load up that internal RAM. But because we're using this new method of loading the data into the CPU, we don't need any of that. So that's all gone. So let's go ahead and we'll go back to the new design and we'll look at the top level. So this is us back in the new design, and we've removed all of that extra stuff within the control unit. So let's go to the top level and we'll see what we've had to do in the top level. So now we've replaced the RAM with a RAM element that we get from Logisim. So if you come down here and you get into the memory, you can go to RAM, and that's the RAM element there. And you've got an option here to make it separate load and store. So that will give you an input to the device, a RAM, so whenever you want to write data into it, and an output from it, so whenever you want to read data out of it. And the A is the address for it. So that's what we have up here. We have a RAM. The address is going to come from our new bus, which is the memory address register. So in effect here, this is like a little 8-bit bus. And it's coming from the memory address register, which is here. So this is our address bus coming in to the RAM and telling us which address we're going to be working on. We have the data coming in from the bus. So that's the output from the CPU, comes in this data bus and goes in to this point here. So you can think of this as an address bus and a data bus. Now, in order to clock the information in and out of the RAM, again we're going to use a RAM set and a RAM enable. So in order to set the RAM, we use a RAM set in this little clock point here. So this clocks in the RAM position from the memory address register. Now, whenever we want to read the information out, we're going to have to enable the RAM onto the bus. And we enable the RAM with the RAM enable. And it goes through a little buffer, and this buffer will connect it from here on to the pin here that's called data. So the tunnel's called data. This data tunnel, again, it's really the bus again, but it's a bus coming out and going back in to the bus input here. So the route that they're going to take is we're going to go from the output from the CPU comes along to this point here, and then the input from the CPU comes from here down along and back into the input. So that's how it's set up now, and it's an awful lot simpler using this, and you'll see that just in a minute if I make this a little bit bigger for us. Now let's try out an example to make sure that this is working. We really need an example that's going to write to the RAM and then read from the RAM. So we need an example with a load and the store instructions. So if you note in the resources section, you're going to have a copy of this Logisim file, so you can open this up and have a play with it. Also, there's going to be a file there which is an Excel spreadsheet. So this is our assembler debugger. So if you open up that file, and I'm going to use an example of the Fibonacci numbers, and we generated the Fibonacci numbers and we sent them out to a memory location. Now, if you have a different program you'd like to test it on yours, you can go ahead and do that, but this is a program I'm going to use. So if you get into sample programs, you'll see that there's one called Fibonacci. So if I can go Control C and I can get into the debugger and put it into column C, that's Control V, and we can go assemble pass 1, assemble pass 2, and then we can start working through the debugger. Now this program is going to output the values for the Fibonacci numbers to an address. So there's the address here. You can see it going, it's a value of 1, and it stays at 1, and then it goes to 2, and then it'll have to go up to 3, 5, and 8, and so on and so forth. So if I just press escape, you'll see these numbers counting up, and you can see it 5, 8, 13, 21, 34, 55, 89. So that's counting all the way up until it comes to a stop. And it's putting it into this memory location here, so an address in RAM, and we're going to see that address in RAM whenever we run through the example. So we can export that and we can place it in your folder. So my folder here is going to be in here, so it's just in original files, that's my sim. Okay, so it's going to be there, Control C and Control V. Okay, so that's me outputted it to that particular folder, and now I can load it up, edit contents, open my sim, and that's us now opened it up. So the beauty here is that we can just start running this. We don't need to go loading in all 256 bytes. It'll just automatically start running. So I'll run this through to the very end, okay? Just quickly. In fact, I'll slow it down a little bit. Maybe make it 2 kilohertz and tick enable, and you'll be able to see the numbers running. So there's the Fibonacci numbers there. So 5, 8, and it's 0D, 1, 5. So these are in hex, and these are the Fibonacci numbers for the hex. And that's it stopped at the very last one. So you'll notice here as well, if I get into the edit contents, you'll see here we've got the end of the program here, which is CF, and we've also got another couple of values here added, and the very last value here was the last value of the, or this value here is the last value of the Fibonacci numbers that we put in. So it is writing to those values and address in the RAM, and it is reading from the RAM back out. Now I think that's enough for this video. If you like, you can download the Logisim file, and you can download the Excel spreadsheet, and you can run the simulation for yourself, and you can step through the simulation one little block at a time with the clock here, and follow every single 1 and 0 through the system and ensure you understand what's happening with it. So that's all for this video. I think in the next video we will take what we have here and we'll port it into the Logisim Evolution. So thank you for listening. I'll get you next video. Goodbye.